Okay, in today's video we will be going through the optimizer and then finishing up this little neural net that we're making. So make a class called optimizer. Let's call it optimizer. And it'd be pretty simple as of right now. Make a learning rate 0.01. Okay, so we'll make that, and then want everything public still. Let's see. We can make the learning rate variable be private, but that should make that work. And then we'll just have a function to update the parameters. And that'll take in a layer dense layer. Pretty simple. And all this is going to do is getting ahead of myself. Alright, so all this is going to do is we're going to go through the layers weights, go through the rows and the columns, and we're going to update those weights using the gradients that we made. And you just subtract the learning rate times those gradients, or the derivatives of the weights. And that's it for the weights part. And then if, gotta check if you have a bias, if you have a layer bias. The layer has a layer bias. Then for I in the layer layer dot biases, that's what I want. Dot calls. Go through all the columns of it because it's a 1 by however many columns. And we'll update the biases 0, I minus equals learning rate times learning rate times the debiases 0, I. And that is all you do for an update. Need one of those there. And we can go back to the main function here. We'll throw in this optimizer. Let's call it opt. It'll preset a learning rate, but you could otherwise put in a learning rate. But it already has that set in for this one, so we'll just leave that. Now we'll go ahead and throw all of this into a for loop. This count, we'll call it number of iterations or num iters. Make it int num iterations. Let's say 300. I'll also make a check iter. So every once in a while, let's say 30. So every 30 loops through, we're going to check, see what the output of the sigmoid is and how it compares to the true values. But yeah, we'll throw all this in there. I'll just go to there. Delete that. And these output and losses, we'll do an if I modulus check iter equals 0. And here okay, so this is sig output, sigmoid output, and the losses. Actually, instead of doing the losses, I'd rather just do the true values. Cause y true. And that'll be, actually, I guess we already know what they are, so we really don't need that. They'll always be, the y true will be 0, 1, 1, 1. So, outputting the sigmoid, let's see, loss forward, you don't really need the loss forward. You can definitely use it if you want to output the losses in this if statement. You do not want to output any, you don't want to print anything out here. If we're doing 300 iterations, you'll get 300 of it. All right. And if I haven't messed anything up yet, well, let's find out what happens. I mean, I know I did forget to put the optimizer updates down here. Let's see here. Let's do that. I always forget if that needs parentheses or not. And then we'll do opt.update. Let's see. Let's actually make this a float first of all. Make that a float. Equals 0.01. LR equals the learning rate. Optimizer. Did I save this? Save this. Come back here. Right here. Okay, so that should be fine. Dot update params. Yeah, I think I just didn't save it. So I like to start with the most recent one and go backwards. You don't need to. Alright, well, let's see what happens now. Calls, vcalls. Outputs. Okay, so there's something. Input dimension, number of neurons, number of samples will be 4. Neurons is 2. Output is 1. I think this should be number of samples, yeah. Samples. No. That should be number of neurons. That was right. Okay, so now we just need to find out where this is off. Okay, number of samples 4. Okay, that's what's off. So that actually needs to be 3. Because this is I will be each row, and each row has 3 columns. So I times 3, so 0 has the first set of numbers. I times 3, if I is 1, that'll be 1 times 3, which will pop up here, and so on. So that is where that issue should come from. And yeah, so sometimes this happens. And how I fix this is finding out where it's at. Do that and make this 2 iterations. You just start commenting out stuff and see what is the failure point. So that worked just fine. And it's best to take a computer science approach to this. Always cut in half. That's faster. Okay, so it's in here. We will do these. It should be the loss anyways, because that's the newest thing we've added. Okay, so let's see. Inputs. Interesting. And that's where we fail. Two backwards sig.d inputs. Neurons by num neurons. That's why. Because this needs to be num outputs. And that's how you find where your issues are. So Lairdens 2 needs the same output as the sigmoid output. We will save that. And okay, now it works. Cool. Come back, uncomment all of these. Make sure that it all works with like 2 iterations. Okay, it all works. And now crank up the number of iterations and see if we learn anything. And we have an issue. Let's see. Well, let's go ahead and make it 1 row deeper. Not sure what's happening here. I'm gonna guess something blows up. Let's not make it deeper yet. Forward. Let's go with 2 iterations, 1 on the check iteration. Let's go with 5. We'll see where it blows up at. Okay, so that's going in the right way. That one's going in the right way. This one's going in the right way. 0.503 to 0.506. That's going in the wrong way, which could be okay for now. Let's make this 5 out of 50. everything's going up to 1. And that could be where the problem was coming from. And this could be where we need a little additional depth. And I'm sure there's different ways to do that as well, but let's try to make a little more depth in this. 3. So the second one we'll need to change to num neurons. Make a third one there. And we'll make an extra ReLU to num samples, comma, num neurons. Because these are only in the in-between stages. So then you gotta come up here and fix these. So forward LD2, and this will go to ReLU2, LD2, forward LD2 dot output, and then we'll do LD3 dot forward of that, 2 dot output, and then the sigmoid will take LD3, layer dense 3 output, and then going backwards, we'll actually have LD3 go backward on the sigmoid, the inputs, and then ReLU2 go backward on LD3 dot D inputs. And then we gotta change this LD2 to actually take the ReLU2 D inputs. And then we also need to modify the optimizer, update. Need to update the weights for LD3 as well. And let's see what that can do for us. So 0.3, 0.53. See if we come down here and we still have that all going to 1. Interesting. This shouldn't make a difference, but in my other file I've made a slight difference, but